Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video, another video in our series of videos dealing with the standard normal transformation, is going to look at a particular example, a particular scenario. In this scenario we're still talking about 3-bed semi-detached houses in a certain town, but the scenario is this, is that the value of 3-bed semi-detached houses in a certain town is normally distributed, which is brilliant because once again we know that this model with respect to these bell-shaped curves, these normal curves, these standard normal curves applies. Right? But the characteristics of this particular population is that the mean price of houses is €420,000 with an associated standard deviation of €60,000. Okay, and what I'd like to actually try to calculate is, I suppose, what proportion, okay, what proportion okay, of houses, okay, would have let's say a value let's say between okay, let's say €480,000 and let's say €540,000. Okay, so what proportion of houses would have a value between 480,000 and 500,000? Knowing that the house prices are normally distributed, knowing that the average house price is €420,000, and knowing that the standard deviation is €60,000. So can we estimate what proportion of houses we'd expect to have a value between 480 and 540,000 euros? Okay. So I suppose the first thing that we should always do is identify the population parameters, in particular the population mean and the population standard deviation. Now the mean is given here. The mean is €420,000, so mu is equal to €420,000. Okay, and the standard deviation is equal to, the standard deviation in this example is equal to €60,000, so sigma is equal to 60,000. Okay. So what we should now try to do is we know that the scenario that house prices are normally distributed. Okay, normally distributed here. Okay, so what we should do is we should plot all of our information on a normal curve that has these parameters, that's centered on 420,000 and that has a standard deviation of €60,000. So let's do that. So let's draw a normal curve. So here's a normal curve, I think. Yep. Okay, there's a normal curve. Okay, and I'm going to make this normal curve its center point because the mean of this particular curve, the mean of house prices is €420,000. So the center is 420,000. Okay, that's the center there. Okay, and the standard deviation is 60,000. So we'll just assume that the standard deviation for this curve is 60,000 euros. Okay, it'd be hard to actually draw that. Okay. Now we're interested in what proportion of houses would have a value between 480,000 and 540,000. Well, look, 480,000 is bigger than 420, so it must be around here somewhere. Let's say 480,000 euros, and 540,000 is bigger than 480, so it must be around here. 540, let's say, thousand. Okay. These are house prices. Okay? So we're interested in between these two values. So we're actually interested in the area under the curve that's between these two values here. So we're actually interested in this particular area under the curve. This area right here under the curve is the proportion of houses, okay, that have a value between 480 and 540,000 euros. So how can we do that? Well, what we'll do is we transform. Okay, so we'll transform this particular problem into a problem that's based on the standard normal curve, which is associated with the z variable, okay, a standard normal variable, and the transform is z is equal to x minus mu over sigma. Okay, now we already know that the center point is always going to go to 0, so when x is equal to 420,000, we know that the z-score that goes along with it is 0 because the center of this curve is going to go to the center of this new curve. Okay, so we don't need to do the center points. These are the trivial cases. We don't need to figure out what the z-scores are associated with these center points of our curve. They're always going to be equal to 0. But what about 480,000? So when x is 480,000, where is the z value for that? So z is equal to the x value, which is 480,000, minus the mu for this particular population. The mu is 420,000. Okay, divided by the sigma, which is the standard deviation, which is 60,000. Okay, so what do we end up with here?